the recording server. And welcome to our instructor trainer course, Scaling Networks version 6, second class meeting, second or third? Second, third, I don't remember. It's welcome to our meeting for this week, for the week of 10, 3, 4, somewhere in there. It's a long week. That's duck season's coming in North Carolina, so I have not had a lot of sleep this week so far. Today we're going to talk about the scaling networks or scaling VLANs, but what I want to do is real quickly, I was going through assignments and I want the class to be aware of something. I know we have due dates on assignments, but I had some folks turn in assignments that they didn't get fully completed because of the assignment due date. It's much more important for me that you complete the assignment fully, understand what's going on, and instead of hitting the due date for this course. So for my instructor training courses, it is really very important for you to learn the information, obviously. So please don't feel like it's due on the 4th or the 3rd or the 8th or the 1st or whatever, and you've got to get it in right then. Complete the assignment fully, understand what you're doing, ask me any questions you have on it, and then get it in, and I will grade it. I will grade anything that's turned in late. That's not a problem. I don't. Those due dates are just to make it work if you're like me, which is if I don't have any due date whatsoever, I won't do the work because I have so many other things going on just like you do. So please be aware of that. Again, complete the assignments and get them done fully. Don't just finish what you can and then get it in by the arbitrary due date or the due date. So, all right, I want to talk a little bit about VLANs. We know what VLANs are. Or we should at this point know what a VLAN is, because when we think about what a VLAN is, it is a logical segmentation of really the ports on a switch. And really, I always tell students, when you think about a VLAN, just consider this. And I always say, hey, look, VLAN equals network. That's what it is. Okay, so it's going to be a subnet. Each VLAN is a subnet or a separate network. They are logical divisions, and we can do it based upon ports. So when we're looking at, and I'm actually going to pull up, I should have NetLabs already open somewhere. I know I do because I have this lab. But we've got 3 switches here. And traditionally, when we were going through creating VLANs, what we learned to do is we learned to go to each individual switch and create the VLAN. So in other words, on switch 1, if we needed VLANs 10, 20, 30, we had to go into the config mode, type in under global config, I'm going to pound here. We do VLAN 10, we'd get the config VLAN subinterface mode, and then we could give it a name and whatever else we wanted to do. But this very quickly in a large organization becomes a problem, because every time you add a new VLAN, you have to go to every switch and you have to create the VLAN, name it, and I know naming is not necessarily absolutely necessary, but it's good to have in the database, because really the thing that matters is this tag, this 8021Q tag that's dropped in to the identifier on the frame. But still, you have to do that. In addition, don't forget the second part of creating VLANs is putting ports in the VLAN. So that is a very important part of the 2-part process. So once we start scaling networks to a bigger environment, it's much more difficult to do VLANs in this fashion. So what has been developed is a protocol called VTP. So it's the VLAN trunking protocol. Now this is very important that you see in the name that is the VLAN trunking protocol, which means in order for the VTP to work, you need to have trunks between your switches. Hence the name VLAN trunking protocol. We really try to keep this stuff as simple as we can, folks, so that it's pretty easy to understand. But what it does is you can take a switch and you can make it have one of 2 different, well, really 3 different functions. And we're going to talk about a VTP server, a VTP client, and then a transparent switch in a VTP environment. But we're going to develop it so that we can instead of having to go to every single switch, we can set up BTP servers, let's say at the distribution or the core layer, probably distribution. And let me explain something to you also. For a long time, BTP was in the CCNA curriculum. They took it out because they said, we're going to go to an environment where everybody is routing between their buildings. They're not going to have a flat layer 2 network across a large campus infrastructure. And that we don't. Like now here on our campus, each individual building is routed to, and then inside the building, you have switches with the VLANs on. In fact, just one switch in this building because it's a big switch. But what they found out was even when you're routing to the edge, you may have a building that has 15, 20 switches in it. So every time you want to put in a new switch or you want to put in a new VLAN, you had to touch every one of those. So they backpedaled and they actually brought BTP back into the CCNA. Traditionally, we could set up a BTP server at the distribution or core layer and then have those propagate down to client switches, the BTPs that are created. Now, key point there. Remember I said there's two parts to creating a VLAN. One on a switch. One is obviously you create the VLAN, and the other part is you put ports in VLAN. And this is this right here is what BTP helps with. It cannot do this. You still have to go and put your ports in your VLANs. Either statically assigning the ports with a switch port access VLAN command, or there are other ways to do it, but most of us just put ports in the VLANs. You can dynamically have ports put in VLANs based upon policies. The beauty of BTP is that it does save you a huge amount of work in larger environments where you have it within a building, or even if you may have a smaller network that is a flat layer 2 network, it keeps you from having to touch every switch when you create a VLAN. Now, BTP only learns about what is called normal range VLANs, which is any ID from 1 to 1005. For BTP version 1 or 2, BTP version 3 does support extended VLANs, but it's kind of like, I always say this is my, this statement right here, BTP version 3 does support extended VLANs, but is beyond the scope of this course. In other words, I'll turn on my camera for just a second for you. These are not the droids you're looking for, okay? So that's the statement. These are not the droids you're looking for. It's basically saying, yeah, of course it's here, but don't worry about it. It's something later. BTP does store your VLAN configuration in the exact same file in Flash that is stored as normal VLAN information, which is VLAN.dat. So let's take a peek at our components. The BTP domain is one or more interconnected switches, and it has a name. The best way to describe the BTP domain name is like a work group name in the old Windows-based computing back in the day. There are BTP advertisements where each BTP domain sends out information. Inside of the domain itself, too, there's going to be what's called a revision number on the switch, the VLAN database on the switch. That revision number will basically allow a switch to see if it's running the latest version of the VLAN database for the BTP domain. There's going to be a BTP mode of client, server, or transparent. We'll go into more of those in a minute. And then a password that has to be shared between each of the BTP members in order for them to accept and exchange BTP information with one another. Now, you don't have to do a BTP password, but it is, of course, highly, highly recommended. So, BTP modes. If you are a server, you have a read-write version of the VLAN database for the BTP domain. So, very important here, BTP servers, they got a read-write version of VLAN database. All right. So, a BTP client, what do you think it has? It's read-only, not a RRO. It's a read-only version of the database. it can only get its database from a VTP server. Okay? And again, it uses that revision number to determine if it's running the latest version. In addition, this last little item here is a VTP mode of transparent. Now, what a transparent does is it has its own separate VLAN database. In other words, it really doesn't participate in VTP whatsoever, except for one thing. It forwards VTP advertisements. So that's the difference between having a switch that does not participate at all in the VTP domain and one that has the ability to forward the advertisements while not actually using the VTP database from the VTP domain. Welcome, Sandella. How are you? So these modes are pretty easy to set on a switch. Let me go back one more time here so I can put this up. So VTP server, you can manage the domain, you can create VLANs, you can delete VLANs, you can name VLANs, participates fully, and it does save the VLAN information to the VLAN.dat on reboot, and it can update other VTP switches. The VTP client cannot update other VTP clients as far as sending out the actual database to with changes in it. It does participate fully, so it can forward the databases, but it cannot actually update or create or manage VLANs on it. Another neat thing, or neat in some ways, about the VTP client is if it reboots, it will not have any of the VLANs on it because the VLAN configuration is not stored in the VLAN.dat file. It would have to go to the VTP server and pull down a new copy when you rebooted it. And then the last is VTP Transparent, which has its own database and only forwards those. It does not actually have the ability to update other VTP switches, so it doesn't send out any database on its own or any VTP advertisements that come from it. It only forwards advertisements from other devices in the VTP domain. So, any questions on those three modes?
What if the client, VTP client, happens to need a reboot for some other reason? Does it have to get it from the server again?
Yep, sure enough. Yep. When the VTP client reboots, what it's going to do is it's going to boot up, and what's going to actually happen is until it pulls down the VTP information from the VTP server, you will have ports that are orphaned because they won't have the VLAN database information. But it will go out and get it, and then it will pull it into the running config and load it, and you shouldn't have a problem. It just may take the switch a little longer to come up than it would otherwise.
Okay.
So you're saying that the ports will stay intact?
Correct.
Come back? Okay.
Yeah, because think about it. Remember, there's two parts to this VLAN configuration: creating the VLANs and putting the ports in the VLANs with a switch port mode access, and then switch port access VLAN command. Well, those switch port access VLAN commands are stored in the startup configuration for each port. So the ports would still be in the VLANs. The VLANs simply wouldn't exist until they were pulled down. Does that make sense, John?
Yep.
All right. So here's the beauty. It's easy because basically you put in a new VLANs added. You can send what's called a summary advertisement that tells all adjacent switches of the domain name and the configuration revision number. And this is that number that tells you what version of the database is being used. So basically say, hey, we're part of this domain, and we are using this revision number. Then there's an advertisement request, and so summary advertisement say, hey, I'm part of this domain. Can you send me an advertisement or give me the information about the VLANs because you've got a higher configuration register number. So they're exchanging information, and switch 2 says, hey, I've got a higher revision number. Then switch 1 would say, hey, can you send me that? Now, this is, of course, doesn't matter whether it's a VTP server or client in this case. It could be either one because two servers could exchange information with each other about revision number. And that's actually where things become dangerous with VTP, because let's imagine Okay, here's a really bad situation we're going to talk about in the next slide too, though. By the way, we get the advertisement request and you get the subset so you can get any changes. But let's imagine that you are working in a lab, and I'm going to actually go ahead and go out to this caveat because this is a really big caveat. Let's imagine you're working in a lab and your school's BTP domain name, for whatever reason, is Cisco 1. You've got a switch in the lab. You've set it up as a BTP server. You have added and deleted VLANs on it for 2 weeks. And that revision number is now much higher than any other switch in your environment. And then that switch does not get wiped out, does not get erased and reloaded before you connect it to your network. What's going to happen here, okay, so imagine this. Let's imagine this happens, and it's a horrible thing, but by default, when you turn on BTP, a machine is a BTP, or a switch is a BTP server. It joins the network with this Cisco 1 BTP domain name, a revision number of 35. Everybody else is sitting at revision 10, and in your production network, you need VLANs 10 and 20 for your network to work. This switch is going to send out advertisement. Okay, so it's going to send it out and say, hey, I've got a configuration revision number of 35. And then S3 is going to update its database, S1 will update its database, and S2 would update its database, and all of a sudden, VLANs 10 and 20 are going away, and the only VLANs you're going to have are 30 and 40, and your entire network just went down. So, if you don't want to lose your job, which is typically what happens, especially think about it if it's a very large environment, okay, you're going to want to, before you ever put a switch into an environment that you've been playing on BTP, change the domain to something that's non-existent, and then change it back to the original name so it resets the revision number. I would also say you can delete the VLAN.dat, change the domain name, and then reboot it, and that will also take care of it. So be very careful when you do that, when you're putting it onto the network. So it can be very bad. So any questions about it? We got a whole nother slide on it. We'll show it to you again, but I just want to make you aware of that when we got to the beginning of BTP here.
No questions here.
Okay. Version 1 supports BTP mode on all switches.
Kevin, can you hear me?
Yeah, I got you. How are you?
I'm doing all right. I'm actually still at Cisco right now. But had you already talked about the situation if you ended up having a low MAC address, an older switch being put in the environment, or did I miss that part?
I did not talk about it. I don't know if they actually mentioned that in here, but that could be an issue too. Do you want to go ahead and talk about it?
Oh,
yeah.
Well, it's just essentially that if you end up having the type of an election where it goes by the lowest MAC address, if you end up having an older switch knocking about it, it can end up, causing some type of a loop or bring your whole network down. Yeah,
and I believe that's what spanning tree, when we're thinking about spanning tree elections. Yeah, the MAC address is not used with BTP, VLAN trunking protocol. Now later on when we talk about spanning tree, yeah, that's a big issue, and we'll talk about bridge IDs and that. But no, I have not talked about that yet, but we're getting there later in the chapter. So here's the default BTP configuration. If you do show BTP status, it's capable of running any from 1 to 3. By default, it's running 1. Also, by default, there's no domain name. So in other words, it's not enabled. And you're in transparent mode. So in other words, by default, you're going to send any BTP advertisements that come to you back out, but you're not going to create any yourself. All right. And then BTP pruning, that's a mode that basically if you don't have a VLAN on your switch, a port in the switch, you will not put that VLAN in the database. It's not really talked about much in this particular chapter. All right, so let's look at BTP configuration. First off, again, remember, It's the VLAN trunking protocol. Therefore, you don't have trunks, you don't have VTP. So we need to make sure you realize that we need to have trunks between the switches first. Once those trunks are up, you know, switch port mode trunk, switch port trunk, native VLAN, whatever, and switch port trunk, loud VLANs. Those are the 3 commands that 99% of the people do. And Scotty, yep, that could be talking about connecting to a client. Yep, but that's not enough. I would say you need to change the VTP domain name to a different name, and then back to the original, and then that way it would clear out the VTP configuration revision number completely. I'm very careful with VTP because it can be a mess. But as far as basic configuration, it's very easy. You configure at least one server. It's preferred you have more than one, obviously. Configure the VTP domain name and the password. Configure your clients, and then configure the VLANs on the VTP server, and then they will propagate down to the other devices. So what I'm going to do, I'm actually going to go through in NetLabs real quick, and I'm going to set up VTP. Just to show you, I'm going to be like Missouri. I'm going to do the show me state. And I'm also going to do something kind of cool that one of my other instructors asked me to do this the other day, and I was like, you know why I thought of this? So that y'all can actually see the stuff better. And I actually need to do and of course I can't get custom color background. Let's do black, and let's do okay. Custom colors text. Let's go old school. All right. So I'm in the switch. I'm just going to give it a name, T host S1. All right. Now I'm going to do a quick do show VTP status, and you'll see that it is exactly what they were saying. It's version 1.3. It's capable of running any of them, and right now, in this one, it's a server, and actually the default mode is server, not transparent. So I don't know why they put that in there. Let me back up. I thought it was a little weird. Yeah, default mode is server, not transparent. Okay. All right. Thought maybe it changed in iOS 15, but it has not. It is server. Let me change. I got my color preset wrong. Background. I need actually black. Much better. Okay. Now, I'm gonna take and do VTP mode server, and I know it's already server, but I'm paranoid. I like to go ahead and make it myself. VTP domain, and I'm gonna give it a name of I don't know, Bubba. All right. And then I'm going to go VTP password. I'm going to Cisco. Don't ever use Cisco. And now if I do show VTP status, you will see that I'm a server for the VTP domain of Bubba. And here's a command that a lot of people don't know about. You can actually do show VTP password, and it will show you what the password is. So you can actually see what do show VTP password, and it shows you that password. Now I'm going to create my VLANs. VLAN 10, name students. And I'm going to do VLAN 20, name teachers. All right, just do it that way. Now we'll go down here to S2. And real quick, change of preferences again. I hope I can actually, I need to be able to set my own. I do actually like the fact that it does an automatic for you in terms of showing you. That's a little bit greener there. I'll make it a little bit bigger for you so you can see it a little better. Okay, now on S2, let's go in here. And I don't know why it has already got config on it, but let's do CLASS. right, I'm going to try one more thing, then I'm going to back up and punt. Yep, I had to reboot this one and reset it. We'll go to S3. Don't you love live demonstrations? And I'm not going to change anything on this one, y'all, because I'm on config t host S3. I will make it bigger. Go with 15. I think that's pretty good. Is that big enough? Everybody can see it? Okay. So BTP mode client, BTP domain, got to spell it right, Bubba, BTP password, Cisco. Okay. So now, do show VLAN. Should be getting the VLAN. What's going on? Anybody know? I did this on purpose, by the way, y'all.
The trunk port?
Yeah, I didn't say any trunk, folks. So we got to go int FA03 switch port mode, and I'm going to be lazy and just do switch port mode trunk. And then we'll go back over to S1, and I'm going to go int FA03 switch port mode trunk. And what should happen now is I should get my VLANs. Okay, go ahead. There you go. Thank you. And look at that. VLAN 10 and VLAN 20 are learned or have been learned from S1, because when I do show VTP status, you will see that this is a client. In fact, if I go into global config and I go VLAN, God, I can't type, VLAN 30, it says, sorry, you cannot do this. And I can go back over here and go VLAN 30, name management, oops, management, I can't type, name management. And then it will eventually be propagated over to switch 3. Okay, and it may take it a little bit because it does have to go through the advertisement process, but it will be propagated over. So these are, that's how simple it is. I mean, it was literally what, 3 commands: BTP domain name, or BTP mode, domain name, and then password. So first off, you're going to configure your server, BTP mode server, which by default it is a server. Then you're going to set your domain name and password. So your BTP domain name is any word that's an ASCII word, so any text word basically, and it will tell you it changed it. And then set your BTP password. All right. And then you configure your clients and make your VLANs. And once you make your VLANs, they will be propagated over into your clients.
What about the ports? Are they assigned after it's propagated?
Yes. What you do then is just like you would on any in a normal. So like I'm over here on VLAN or S3, and let's do this. Let's go and say config t int fa0 / actually let's do a range. God, my phone's blowing up. Sorry, y'all. Oh, what's going on here? Oh, motion camera at the house. Interface range fa0 / 10 to 15, and let you do a range to switch port mode access, switch port access VLAN, and we'll just say 10. Okay. Now to do show VLAN, you'll see that all those ports have been moved, 10 through 15 have been moved into VLAN 10. So, and I'll tell you exactly why I'm not seeing this over here. The reason, now this is an interesting thing. Watch this. Let me see if I can show this to you. This is a remnant. Yep, what that is. This is a remnant of where the VLANs used to be in the VLAN database and the way you configured VLANs on Cisco iOS, you'll notice I've created VLAN 30. Okay, so I mean, you see, I've done it. I've given it VLAN 30. I gave it a name of management. But if I do a do show VLAN, you'll see it's not here yet. And you also notice it hasn't propagated over to switch 3 yet. Okay, so when I look here, there's no VLAN 30 yet. The way the iOS works, until I actually exit config VLAN mode, it is not written into the database. The second that I exit, notice again, it's not here now, even though I've actually created it, but I'm in config VLAN mode. Until I exit config VLAN mode, it does not get placed into the VLAN.dat file, and then it cannot be propagated. So if you find that problem, it is because you're still in configuration mode, and you haven't exited config-VLAN mode. Very, very common thing I see with students. Now watch this. You'll see here, now you got VLAN 30 over here, because as soon as it's put into the database on the server, it will be propagated over to the client within the window of advertisement. So that is a very common problem you see when people are creating VLANs inside of BTP, and it won't be propagated. They simply have stayed in this mode, and until you exit it, it will not write it. I'm glad that actually happened, because that's a neat little problem that crops up when you're doing these labs and when you're doing this in the real world too. All right, so that's pretty much BTP, to be quite honest with you. It's nothing really big on that. Here's some of the different things we have about VLAN ranges. First off, any question on BTP? It's a simple little protocol that can cause massive problems and mess it up.
So it only advertises the domain name as a VLAN. It doesn't do anything with the ports.
Correct. It does nothing with the ports whatsoever.
Okay.
Yep. That is correct. That part is you still have to go to each. It's just like I said right here, Scotty. You still have to go. The only thing that BTP will help you with is with the actual creating the VLANs.
Gotcha. So,
I'm muted. And so, but you still have to touch each individual switch to put the ports in the VLANs.
okay, that's what you're saying about it causing issues. Then it could remove the other VLANs that you have set to be a client.
Right. If it's the problem is if you set it to be a server and you're playing,
Okay.
you're sitting there and you're working with the VLAN name. So in this case it was Bubba. If you were to work with a switch off, basically a switch that had the same domain name and the revision number went up. So for instance, when I look here, you see, let me go back to here. If I do show BTP status, you will see my revision number, okay? So right now the configuration revision is 3. But if I had another switch that's not connected to this network that I was playing with in a lab with the BTP domain name of Bubba, and I kept adding VLANs and doing things, and that revision number went above 3, and then I connected into the working network, all of the other machines in that BTP domain are going to update to that version of the VLAN database.
Okay.
And you can end up with a mess. You can end up with, again, the problem where you have all of the VLANs that you need in your network go away.
Right. Okay. I understand that now.
Okay.
Thanks.
Larry, I muted you because I was getting a little bit of background noise from you, but if you... All right. So, let's move on to VLAN ranges. We have normal range VLANs, which are those 1 to 1005. There's a couple reserved 1002 to 1005, which are for FIDI, which is fiber, token ring, and then TRNet, which, quite honestly, I'd have to look that up. I don't remember what TRNet stands for. Then we have extended range VLANs in case you need more than 1,000 VLANs for some reason. So 1006 to 4096. They are a little different because they have fewer features, and the extended range VLANs are actually stored in the running config instead of the VLAN.dat. So the problem, the reason why 4096 is the max is because there are only 12 bits in the VLAN ID field in the IEEE 8021Q header, which is .1Q. So our VLAN tagging can only support up to 4096. If you need to create a VLAN, you can do it by doing obviously just VLAN, the ID, and if you use a number beyond 1005, you will be creating an extended VLAN and giving a name. There used to be a way on older switches where you could actually do VLAN, 10, name, whatever. I wish we could still do that. I wish we could do it all as one thing and then it just dropped you into config VLAN mode. You can also do a series of VLANs and actually enter commands on multiple VLANs at one time. And they show you the command show VLAN brief, which is another good command. But here's a sample VLAN configuration. So pretty easy there. Assigning ports to the VLAN. All right. So in other words, when we create a VLAN, and we then need to assign a port to it. So we create it, and then we go to each individual port or use the range command like I showed you. And you go in and do switch port mode access. This turns off another protocol we're going to talk about today, which is dynamic trunking protocol, which I don't like at all from a security standpoint. But switch port mode access makes the port into an access port and therefore turns off DTP. And then switch port access VLAN, and then the number will force the switch to tag that port with the VLAN ID that you assign here. So once a frame comes into the switch, it will be tagged with that VLAN ID. So if I want 018 to be part of VLAN 20, I go in and do switch port mode access, and then switch port access VLAN 20. And then they have a little syntax checker here, so you can go through and do the activity. Show VLAN brief. You can do a show VLAN and do an individual ID. So here's show VLAN name student. That would just show your student VLAN. Okay. Show VLAN summary will tell you the number of VLANs you have. I most of the time just do show VLANs. But show interface VLAN 20. This is if you have an SVI. Remember, this is a switch virtual interface. And it will show you what IP address is on that SVI and Ethernet switch virtual interface. Let's see. Here's your extended VLANs. Depending on the mode, when you're doing extended VLANs, it may be that you have to change the mode to transparent, because remember, a BTP client and a BTP server not running version 3, okay, now if you're running version 3, it does support it. If you're not running at least version 3 of the VLAN trunking protocol, it does not support VLANs above 1005. So if you want to do that and not change the BTP mode or running version number, then you have to go to transparent mode, and then it will let you create any VLANs you want. I have worked with switches for a pretty good while, and I have never configured an extended VLAN. I don't really, I mean, maybe Sandeli, you've seen them, but I mean, 1,000 VLANs on a switch would be nuts in and of itself.
Yeah, and so Kelly, actually I have, and so it's in the
really?
Yeah, for the D Cloud team. So what it is that they have so many different virtualizations. They create these different environments. So it's utilizing virtualization. So you have so many thousands of pods running at one time. And I've actually seen us go over that number. Mm-hmm.
Oh wow. Okay. Well, that makes sense. And I guess if you're MPLS is totally different. Well, okay. I get in that virtualized environment. I could see that too. I could see you having that, but like I said,
you're talking about virtualization and the switches and routers, right?
Correct. Yeah. Or what you're doing, John, is you've got let's say you're running ESXi virtualization, and you've got you're tagging traffic in a port group inside of the server itself. And so you've got so many in a DevOps environment or development environment, you've got so many different virtual switches that you go beyond the 1,000 VLAN, but then you also want those to be able to get out to the real network. So you have to make the Cisco switch or devices connected to that ESXi server, which is a VMware server. It's connected, and it has to support those extended VLAN IDs. So between two ESXi servers that may be connected to each other.
Does Cisco have any classes for virtualization?
They do not. Cisco does not offer a cloud class. You know, there is a CCNA data center. I've completed the first half of the exam for that, and I'm working, now I'm in CyberOps, but the we teach VMware. We teach VMware's I install, configure, manage, and optimize and scale. And we're going to start probably teaching Hyper-V and OpenStack as we move forward. So, unfortunately, no.
Okay. I was just curious about it because I've been wondering about the net labs, and that was one of the things that they have issues with. Is they have to actually use physical routers and switches to develop.
Well, now there are some tools out there that have been developed. GNS3, which is you just have to be careful because technically the legality of using the iOS images on GNS3 is, as long as they were obtained legally, it's okay. Cisco also has this product called Viral, which can do it basically is virtual. They do have a vIOS. In fact, you know, Cisco has a vIOS and a vSwitch. So you got iOS V and iOS V, which means virtualized. This is their virtualized iOS, and this is their virtualized switching iOS. And then they've also got these others, even an ASA virtualized. So you can actually buy access to it like this, or you can actually buy Viral itself. You can actually buy it and then install it. It is not for the faint of heart to install. It is an awesome thing, but it is not an easy thing to set up and kind of learn about. It takes the personal edition, I think, is $100. I can't remember exactly how much it is, but I think it is. And then you've got to put in, I mean, like I'm running ESXi server with connecting to it with Maestro and all types of stuff. So it's pretty hefty to be able to actually to make it work. So, but you can run it if you got a good workstation at home. You actually run it inside of Workstation Pro, so it is possible to actually get it. So if you want to take a look at it, it's Viral, and it is a neat little thing. And you just go buy it.
Okay, Viral, is that what you call it?
Yeah, Viral, V-I-R-L, Viral.
Okay.
So Viral Personal Edition, actually it's $199 for. They went up. They don't have a educator version anymore. They used to have a $79 educator version, but they quit selling it. So, all right. So we've talked about BTP, and we've talked a little bit about extended VLAN. Let's talk now about DTP, which is Dynamic Trunking Protocol. DTP is a protocol that can be used to dynamically create trunks when you connect two switches. What DTP will do, depending on how it's been set up, is it will negotiate and say, hey, I want to be a trunk or not, basically. It is a proprietary protocol. And it is automatically enabled on 2960s and 3560s. I'd have to check on the newer switches. But the problem is, it is a massive security hole, and here's why. Hackers know that this is installed and enabled on Cisco switches by default. So there are hacking tools out there that will take a laptop and have the laptop actually send out DTP information on its Ethernet when it connects to a switch. And so the hacker connects their PC to a switch, and then if DTP is enabled, that switch will then start running a trunk port with the hacker. The hacker will then be able to see all the VLANs. They'll be able to see all the VLAN broadcasts. They will know exactly what's on your network in terms of VLAN. So I'll go ahead and say this: I do not like DTP at all. If you want a trunk do switch port mode trunk. That's my personal opinion. But from a standpoint, it's there. We're going to learn about it because one of the reasons you have to do switch port mode access is because DTP is turned on. So, and what, for instance, can be a problem is by default it's switch port mode dynamic auto, which means, okay, I will become a trunk if the other side asks to become a trunk. And if both sides don't ask, they will sit there and not be a trunk. So we'll talk about the different modes. And here's the different modes. So switch port mode access, your port will become an access port. It will not trunk. In other words, a tagged frame will not exit a switch port mode access port, period, if the tag is removed. If you use the DTP mode of switch port mode dynamic auto, it says the link can become a trunk if the other side wants to become a trunk. The other mode is switch port mode dynamic desirable, which says not only can I become a trunk, I will become a trunk and ask to be a trunk. And that is actually the default, switch port mode dynamic desirable, and that's why it's a security hole. The interface attempts to become a trunk. So if the other side is a trunk or the other side is dynamic auto, it will say, hey, I want to be a trunk port. And we'll make a trunk between the two devices. If the other side is an access port, then it will not. It will become an access port. If you set switch port mode trunk and the other side's dynamic auto, again, it will become a trunk because it will say, hey, you want to be a trunk, be a trunk. Okay. Dynamic desirable trunk and trunk will trunk. But if you have one side set to trunk and one side set to access, statically assigned, you're going to have problems because one side's trying to tag frames and send multi-VLAN traffic across the link. The other side is not. So you're going to have some issues there. And then access obviously is going to be pretty much everything's going to be an access port other than if you accidentally do one side access, one side trunk. So dynamic auto says, hey, I will become one if you ask. And one way to remember this is auto ask. Dynamic, I will become a trunk if you ask me to become a trunk. Dynamic desirable demands to become a trunk. So I'm going to be a trunk because I'm going to demand to be a trunk. And that's the way to remember it. Dynamic auto ask. Dynamic desirable demands to be a trunk. Hey, I got a degree in English, so I had to use it for something. So you can show DTP status, and it will show you what the status is on the trunk, whether or not, on the link, whether or not it's running DTP. And it's really very easy from there. So, let's look at this. If this is dynamic auto, and this side is trunk, what is this link going to be right here? So the link from switch 1, switch 3, dynamic auto to trunk.
Trunk.
Trunk. All right. Dynamic desirable, dynamic auto.
Trunk.
Trunk. Dynamic desirable, trunk.
Trunk.
Okay. Dynamic auto, dynamic auto. It's going to be an access. Because it's going to ask, and it should become an access. Dynamic desirable, dynamic desirable.
Trunk.
Should be a trunk. Let's see if we got it right. Oh, yeah. Good. DTP is pretty simple, folks. And that is chapter 2. Other than we're going to talk about deleting VLAN, so you can actually just delete a VLAN. We got to do some inner VLAN configuration issues. So deleting VLANs, just be careful that you don't orphan ports. So in other words, when you go to delete a VLAN, remove the ports from the VLAN first, then delete the VLAN. If you don't, what can happen is you can actually end up with orphan ports, and they'll go into an amber or an inaccessible mode, basically.
Does it affect the VLAN 1 then, or?
VLAN 1 can never be deleted.
Okay.
All ports are part of VLAN 1. In fact, one of the security things we talk about all the time is you really need to create a black hole VLAN, like VLAN 999, or some people act smart and make it 666, but make a black hole VLAN and stick all your ports into that black hole VLAN. get them out of VLAN 1. The reason people do that is just to make sure that someone can't plug into a port and have access to VLAN 1. Of course, unused switch ports should be shut down also, but some people do create what's called a black hole VLAN. It's not really used in the environment. It's just where you stage all your ports before you put them in those correct VLANs.
Well, what happens with DTP though? Is that
The what?
can it delete that VLAN? DTP?
DTP doesn't delete VLANs. You're talking about VTP. Yeah, VTP. Yeah, you could. I mean, you could, but I mean, what you do is you just create a VLAN called, do VLAN 999 name black hole, and put that on your server, your VTP server. So I mean, I can go like right here, which one? I can go in and say config t VLAN 999 name black hole. Okay. Then I'm gonna say do show. Remember, I gotta type exit, otherwise it won't go. Do show VLAN, and now I've got that VLAN. And you see all my ports 1 to, let's do ports 1 to 10. Let's say I'm not gonna be using ports 1 to 10 on this switch. So I do interface range. I think, I'll make sure I don't get 03. So yeah, I gotta get, let's just do 10 through 24. That'd be better. Interface range FA0/10-24. Switch port mode access. Switch port access VLAN 999. And now what you'll see is all those ports have been moved into a black hole VLAN. Okay, and that VLAN gets propagated by VTP. All right, but that VLAN is never going to be actually used for any traffic. It's just where you stage your VLANs and put them out there to stay. Or not VLANs, so you stage your ports until you move them to a different VLAN. So let's say I'm going to plug port 10 into the teacher VLAN. So I'm going to go FA010, and now once I put the instructor machine on it, I can't type today, folks. You'll see now, do show VLAN. I just moved it out of this black hole VLAN over into VLAN 10, and now I can plug a student machine in there. I meant to do 20, but I can plug a student machine in there, and it's available all on VLAN 10. So I can set them out there in this black hole until I move them to the VLANs I want them to be in. Multi-VLAN issues, having ports, this is if you're doing the old method of inter-VLAN routing. In other words, this should be on VLAN 10, this should be on VLAN 30, so that it can route. Of course, if you leave it on the default VLAN is 1, and you would not be able to get across. So what you need to do is with your sub interfaces on the, on this, just make sure that these two ports, or this port was on VLAN 10, and this port was on VLAN 30. If you're doing a router on a stick, that's where we use our sub interfaces and make sure the sub interfaces are assigned to the correct VLANs. Otherwise, it won't be able to go across. You would also have to make sure that these are trunking, the sub interfaces, and this port right here, make sure it's trunking. Otherwise, you will not be able to send multi-VLAN traffic across. Here's another problem. Let's say you forget to keep your trunks, so you don't have a trunk between S2 and S1. Even though S2 may tag it with VLAN 10, and there's no trunk between S1 and S2, anything that goes across this link will become untagged. And that's really the definition between an access port and a trunk port. Trunk ports can maintain VLAN tags. So, these are basic commands we have here. Switch ports, interface issues, again, could just be you've got either the wrong default VLAN, or you put incorrect IP address on an interface. Very common. Notice here, this is our sub interfaces, encapsulation .1Q100. It's supposed to be VLAN 10, and somebody fat fingered the sub interface, and it's being tagged with 100. And that means it would come in tagged as VLAN 10, and R1 wouldn't have a port on VLAN 10, so it would just drop it. Okay. Very common issue. Things you can do, just go fix it. Okay. And then here are the subnet addresses. Remember again, the problem with VLANs is a VLAN equals network. So if you do not have the correct IP addresses assigned, in this case you put an extra 0, it will not work. And that's pretty much all we've got with this particular chapter. Any questions?
None.
All right, layer 3 does got a little thing on layer 3 switching, but it's not anything massive. Okay. All right, I'm going to stop the sharing, and I'm also going to stop the recording, and then you can ask any questions.